Okay, so part 2 of yesterday, 5-6, is actually we're just going to pick up exactly where we left off on this chart, and I'm going to kind of describe again exactly what everything does. And I know I talked about some of this yesterday, but I just want to go over it again to talk about what the numbers do. We're going to go over every single one and what it does. So first things first, outside numbers, this is a good note to make yourself if you don't have it written down. What I call outside numbers, ones that are not inside the radical, control up and down. They control the vertical, up and down. So it's going to like do things that will either be up or down. That looks horrible. Let me fix that. Whereas inside numbers control my left and right. Now those inside numbers are not to be trusted. They've made bad life decisions and we're not going to trust them. So those things that are like +3, -3 and they're inside, those numbers in jail, they made bad decisions, we're not going to trust them. So notice here, I've got basically the parent function, which is the basic, it's just the most basic one that we've got. But then we've added 3 to the outside. That 3 is on the outside. Can I trust that number?
Yes.
Yes, it's on the outside, I can trust it. So it's an outside number. Does that control left and right or up and down? It controls up and down. I can trust it, so it's going to move my graph 3 units up. And again, just as a rough sketch, I'm going to talk about this one. So here's the basic one. This is what the basic one looks like. So now if I were to move that 3 units up, it's going to look something like 1, 2, 3. It's going to look something like that. That's what that graph should look like. So if you ever had to match something or describe what happened to it, you would just say that this is that graph moved 3 units up. Whereas -4 would move it 4 units down. 1, 2, 3, 4. It still looks exactly the same, just move 4 units down. Now we're going to get to those inside numbers. I call them inside numbers again because they are under the radical. These are numbers that are not to be trusted. Again, bad life decisions, we're not going to trust what they're telling us to do, but they do control the left and the right. They handle our left and right. And he's telling me right here, he's like -2, which totally sounds like go to the left 2. So in fact, we're going to go to the right 2. So what this one would look like, if this is, again, this is y equals the square root of x. Okay, so y equals the square root of x is the basic one, and then when we subtract 2, that's actually going to move us to the right 2. So I'm actually just going to go, instead of being at 0, 0, I'm going to move, instead of being here, I'm going to go 2 units to the right, and then just draw the same thing. So that's this one right here. Just move 2 units to the right. Whereas +1 would move me 1 unit to the left. Yes, sir? Okay, so like see the difference, like look at those first 4 things there, right? Like let me clear this up. Let me get rid of some of this, like all this writing in here. Let me get rid of this. Let me get rid of this. See the +3 and the -4 up top? They are not under radicals, right? They're on the outside. They're outside of the radical. So they're like free. They're not in jail. They're not being contained. Whereas the -2 and the +1 down below, they are in jail. Like they're in that house, if you will. Like they're underneath this radical. So they are being contained, if you will. Like they are underneath there. That's what I mean by like inside or outside numbers. The bottom 2, -2 and +1, they're inside. Whereas the +3 and the -4 up there, they're outside numbers. These 2 numbers control the vertical, and these 2 numbers control the horizontal. We're not going to trust those numbers down below because they made bad life decisions. Now we get to numbers on the outside. So numbers on the outside, again, control up and down. Remember, outside numbers control up and down. So when we talk about a stretch, it is a vertical stretch, up and down. So if you were a cartoon character and I multiplied you by 6, just like this is being multiplied by 6, you would get 6 times taller. But you would also expect that it looks a little thinner. Whereas, so we call that a vertical stretch by a factor of 6 or by 6. You could say vertical stretch by 6 by a factor of 6. Whereas if I were to take your height and multiply by 1/2, you would expect that what I did was I squashed you down. I had to make you shorter. So I squashed you down, so your height got shorter, half as big, and then you would expect that it looked a little wider as well. Now, that is when the numbers that are being multiplied are on the outside. You can trust those numbers. They control the vertical. They're on the outside. When you're multiplying on the inside, again, that is the horizontal. It controls the horizontal. And again, you should not trust these numbers on the inside. They're not trustworthy. So this one looks like it's saying that it is going to be 1/5 as wide as it used to be. But in fact, it's lying to you. Don't trust it. It tells you should do the exact opposite. Instead of being 1/5, it's actually 5 times bigger. This is like 1 divided by 5. So in fact, we're going to multiply by 5. 1/5 is 1 divided by 5. So they're telling us to take x and divide by 5. In fact, we're going to make x 5 times bigger, or stretch it horizontally. It's going to get 5 times wider. Notice that this one underneath here, it still controls the left and the right, and we're still not going to trust it. It says we're going to get, like, it says 3 times that thing. So instead of being 3 times as big, thank you, it's going to be 1/3 as big. We're going to divide by 3 instead. So we're just doing the opposite of inside numbers there. So quick summary. Up and down are on the outside. We can trust numbers on the outside. Inside numbers are left and right. We do not trust inside numbers. So if you're multiplying by 6, everything would get 6 times taller because it's on the outside. Or if you're multiplying by 1/2, it would be half as tall. Inside numbers, if it's 1/5 as wide, remember that controls wide, your left and your right. Think about your body going left and right, that if you would just stretch yourself left and right, that would be either getting wider or thinner. So we're not trusting these numbers. This means it's going to get 5 times as wide because this is an inside number. This will be 1/3 as big because it looks like it's telling us to multiply by 3. Last but not least are these. If you have a negative on the outside of the radical, or if you have a negative on the inside of a radical, we're going to see this a lot today. If you have a negative on the outside of a radical, it means you're going to flip the whole graph across the x-axis, or up and down. So check it out. Across the x-axis, this is the x-axis. So if it looked like this, it's going to flip to here, if I put a negative on the outside. It went from vertical, it went from top to bottom. Whereas that inside one controls the horizontal. If I were to do this one right here, it would flip it across the y-axis. This is the y-axis. It would flip it across this way. I'm just doing a mirror image of whatever I had. So starting with this one, this is where I'm starting. It's all a mirror image of this. If I flip it across the x-axis, it goes down to here. If I flip it across the y-axis, it goes to there. So just remember, like when we're talking about vertical, like it's those outside things that control the vertical. It's the inside things that control the horizontal. So moving from left to right, that's horizontal. Moving up and down, that's vertical. So we're going to deal with that as we go through. Oh, okay. Am I off? I skipped a whole slide. That's why I couldn't figure out what was. Okay, let's start here. It says using f of x as a guide, meaning like start from this. Well, this is what they mean. F of x is equal to the square root of x, or the cube root of x, or whatever. And they want us to describe the transformations, meaning what happened to this graph. So notice that here is the basic graph, like here's that part that we were talking about, equals the square root of x. And then they did this to it. So all they want is the words. What are the words that describe what happened to this? So what did that -2 on the outside do to it?
It made it drop 2 units.
Good. So we're going to just write down 2 units. That's it. That's all we have to do to it. Because all they said was describe the transformation. What happened is it moved down 2 units. Let's go to B. Okay, there's a 3 on the outside. Can we trust that number? Does that number control the vertical or the horizontal? It controls the vertical. So what does a 3 on the outside being multiplied do to the vertical? It's a stretch. So it is a vertical. This is what we have to write. You have to write vertical, horizontal. It's a vertical stretch by 3 or by a factor of 3. These are both ways of saying the exact same thing. By a factor of 3. These are two different ways of saying the exact same thing. A vertical stretch by 3 or by the factor of 3, meaning it's 3 times as large. So these are actually very difficult once we know what they mean. Okay. How about this one?
Up 1 unit.
Yep, up 1 unit. That's all it is. That's all we're doing on these. Now, some of these, we just have to think about what happens.
It's a vertical compression.
Good. It's a vertical. It's definitely on the outside. It's vertical. And it's a compression. It's getting smaller. A stretch and a compression are the opposite things. Like if I compress you, I'm squishing you. If I stretch you, I'm pulling you. Vertical compression by a factor of 1/2. Meaning I'm just multiplying by 1/2. So it looks just like the original graph, except for it's got a vertical compression by a factor of 1/2. What about this one? Okay, so it's going left 4 units. Remember, this is an inside number. It controls the left and the right, and we're not going to trust that number. All right. It's the basic graph, but there's just a negative on the outside. Good. So now here's where we have to be careful. This controls up and down. It's very easy. One of the things that people always say is when they go up and down, that's across the y-axis. That is not true. Check it out. If you're going up and down, like if I'm going from up to down, what I crossed there was not the y-axis. I crossed the x-axis. To go from up to down, I crossed the x-axis. So it's going to be a reflection, or it reflects across the x-axis. We're going to go to different problems that have more than one thing's going on, like G. So let me tell you, I always like to start, and I'll tell you why. There's going to be a reason why that your answers will be more correct. I always start right here. I always start with your up and down, left or right, like those vertical movements.
Would it be 3 units to the left, but with a vertical stretch by 2?
Good. Left, it definitely goes left 3 units. And it is a vertical stretch of 2 units. Or a vertical stretch by a factor of 2. Now, this next one we have to be very careful with, because if you do this in the wrong order, it will not be true. And this is what I want to describe to you first. I'm going to do it exactly the way that I told you, and I'm going to show you why if you do it in the wrong order, it's no longer true. I said do this first, right? So what does this tell me to do? Okay, so first I'm going to shift it to the right 2 units. Now I want to show you the difference here. Like I'm going to show you exactly what happens here, because if you said this in the wrong order, I'll show you why it's not true. Here's the original graph. And first, I'm going to shift it to the right 2. So if I only do the shift to the right 2, it now looks like this. But then what am I going to do?
The y.
Okay, and now I'm going to reflect it over the y. So it is a reflection, or it reflects, reflects over the y-axis. Now here's why that matters what you say first, because you'll be like, why does it matter? Like, because I'm just doing 2 things. So it was over here, 2 units to the right. So if it's going to cross over the y-axis, it needs to be over here, going that way, 2 units to the left now, right? Because it was here, and I need to do a mirror image of that over the y-axis. Now here's why it would not be true if I did it the other way. Don't copy down what I'm about to do because it would not give me the right answer. Let's pretend I did it the other way around. Let's say I started here. And the first thing I did was I reflected it. So now it looks like this. What does that -2 tell me to do? It's telling me to move to the right, which would look like this. And that's not how this should look. We're going to do that shift left and right, that left and right shift before we do the reflection. We're going to do any shifting up and down before we do that reflection. So do not do this part right there. We did this first, and then we'll do the reflection. So if you said this, by the way, if you said this in the reverse order, I would take away points on the test because it's not true the other way around. Okay, so let's talk about what these two things do. Up 3 units. Okay, this one controls the left and right. So we are going to reflect across the y-axis. And again, that always used to confuse me the first time I heard it, because when you're going from left to right, what you're doing is you're going over that line right there, and that line is the y-axis. Okay, there is actually 3 things going on here. There's this, and then there's this. So that's like 3 separate things. I realize that's a -3 out there, but each one of those things does something different. Let's start with the up and down. Let's start from what does that -1 do? Okay, so this is down 1 unit. Okay, and then it's a what? What does the 3 do? It's a vertical stretch. Well, remember, it's like 3 separate things. We know what the negative on the outside does, right? We already said what the negative is going to do to it. The negative is going to be some sort of reflection. But the 3, right there, the 3 is a vertical stretch by a factor of 3. And then it reflects across the x-axis. So 3 things going on there.
Wait, so why is the negative not significant?
It is. The negative is what, here, I'll show you, let me just show you what each piece does. This does that. This, just the 3, is a vertical stretch by a factor of 3. Because if we're multiplying by 3, now you may be like, but that's multiplying by a -3. Well, really what we learned what the negative part does, the negative is a reflection. If that negative is on the outside, it controls up and down, meaning we reflect it across the x-axis. If that negative were on the inside, it would be a reflection across the y-axis. So that's what we're looking for, those negatives. Okay, that was J. Okay, here is the math nerd speak of everything I just told you. All that's showing is what everything does. Everything that I just said there, notice that this controls the vertical, this controls the horizontal, this ends up that you can't trust that number because it's a minus, it means do the opposite of everything. So everything that's listed there is just the math speak of everything that we just did. Okay, so starting with A there, excuse me. Okay, now we're to this part. It says, use the description to write the square root function g. So what they mean is they want us to create, they're giving us the words, they want us to go backwards from what we just did. They're going to tell us what happened to the graph, and we have to figure out what that means number-wise. The parent function f of x is equal to x. So here's what I'm going to write. F of x is equal to, I think I said is equal to x, I meant the square root of x. It's stretched horizontally by a factor of 2. Okay, so let's think about what that means. It's horizontal, so is that going to be an inside or outside number? It's an inside number, which is a number we can't trust. So it's stretched by a horizontally by a factor of 2. So what number will I multiply by on the inside? By 1/2. Because if they're telling me 2, like, then I go, oh yeah, no, I can't do that. I'm going to go and say, okay, well that means that what I need so far is this. 1/2 x. That's just up to here. We're not done yet. I haven't done everything. Because remember, horizontally is an inside number. And like, look, right here, if I told you right now to do a horizontal stretch by a factor of 2, right now that looks like a horizontal by like 1/2. But the truth is we can't trust that number. We don't want to divide by 2. We want to multiply by 2. We're doing the opposite. So horizontal numbers are not numbers you can trust. They're the inside numbers. All right. In addition, it's being reflected across the y-axis. Okay, so think. If it's going across the y-axis, is it moving left and right or up and down? Left and right. Think about the y-axis. Look, here's the y-axis right there. So it moved, if it reflected across that, it moved from either the right to the left or the left to right. So where does the negative go? It goes on the inside. So now we're here. F of x is equal to the square root of negative 1/2 x. And now it said that it is translated 3 units left on the inside because it's moving left and right. So it needs to go. So what we're going to do is we're going to write our final answer is, all we need is the final answer. I was just showing you this in stages, is equal to the square root of negative 1/2 x. And since it said 3 units left and it's an inside number, we're not going to trust it, plus 3. So notice that knowing what all those numbers do is very easy to create the function. Yes, sir? No, not each and every step. You're going to get so good at this that you're not going to do that. I don't do all these steps in my head when I do this. I just kind of create it as I go. Like, honestly, this is what I do. But because we're doing it, like, I go, all right, f of x, I know it's going to be some square root function. I see that there's a factor, horizontal stretch by a factor of 2, and it's reflected across the y-axis. So immediately I go like this. Okay, what else? And it's translated 3 units left, so plus 3, like that. And I make sure that's underneath there. So you can do that too. You just have to know what's happening on each step. I almost do it in stages though, because it reminds me not to eat this elephant all at once. Take it a bite at a time. Deal with it in what does this part mean? What does that part mean? What does that part mean? So like we look at it in sections to kind of get an idea of what's happening. We can even write it down in words if we want to, and then put it all together at the end. So it says the parent function of f of x is equal to the square root of x. It's reflected across the x-axis. So the x-axis is this one, left, like this one right here. That's the x-axis. So is it going to move up and down or left and right? So where will the negative be? It's going to be a negative on the outside. So we've got f of x is equal to the square root of x. There's a negative on the outside, I'm sure of that. It's stretched vertically by a factor of 2. On the outside what? 2. Times 2, like this. So notice that's that 2 there. And it's translated 1 unit up. Plus 1 outside. And the only thing, there you go, there's that original x that was in there. So that's each of the pieces there. I'm just going to color code this real quick just so we can see where it came from. Reflected across the x-axis, that's this. Stretched by vertically by a factor of 2, that's this. Then it's shifted, translated 1 unit up, that's this. Those are all the components coming together. All I did was mess with the parent function to get there. But you have to know what each piece does. So I don't think, listen, I'm going to tell you right now that if you go to another math teacher and you start talking about like which one controls horizontal and vertical and which numbers are in jail, they're going to look at you like you're crazy. But I know for me that this was terrible to learn all the math rules. Like if you look at it this, like from nerd speak, it was like really hard to figure out what all that was doing. So it's kind of nice when you go, what does this number do? What does it do? This piece does what? It moves up and down? Great. Can I trust it? Fantastic. What does this piece do? So if you know what all the pieces do, then it's very easy to manipulate it. So that's what you're going to be doing. You're going to be going backwards and forwards, either creating the functions or interpreting the functions. So it might ask you to sketch the graph. If I had to sketch this graph, then I would just do a rough estimate of what that would look like. So a lot of times, like if it's asking you to get coordinates, then that should be very exact of what it looks like. Are we okay with that? Okay, that's all we've got. Yes, ma'am.
Like with last time we did work, like we got numbers like this, you know what I mean? Is that supposed to change our graphs? Like I just created the numbers, plugged them in, and then plotted them the way that they were, even though it had.
Right, you would still be able to plot every single thing. Like for example.
Like you would just solve it and then just.
Right. So let's say like we already have an idea what this should look like. I already have an idea. This helps me go like it should be the graph. It's going to be reflected vertically. So it's going to be going on the bot. It's going to look something like this. It's going to be down here, except for it's moved up 1. So I'm going to move it up 1. So here, moved up 1, reflected vertically, and stretched by a factor of 2. So it's going to kind of look taller like that. This is going to look something like that. Like that's what I did was just translate it.
And any numbers you can get.
And it's going to match that. If it doesn't, something's off. Either my interpretation was off or my actual numbers are off. So it gives me an idea of what should this look like.